Yeah, good morning. We are back with our classes on metals and non-metals. So let us revise back whatever we have learned, because there was a break of 3-4 days. So according to metals and non-metals chapter, the first part what we studied was physical properties of metals and non-metals. We said metals are, first point, shining, luster. All metals have a shining luster. The only non-metal which have luster is iodine. Then we studied metals are generally hard except lithium, sodium and potassium, which are soft metals and can be cut with a knife. Then we studied metals are malleable. That is, they can all be hammered into sheets. So the most malleable metal, gold and silver. Then we said metals are ductile. They can be drawn into wires. That is the most ductile metal, gold. Then we studied metals are good conductors of heat. And we said that most of the devices which we use for cooking are made up of metals. Boilers are made up of copper, because copper is a good conductor of heat. Then we said they are good conductors of what? Electricity. We said electrical wires are coated with what? PVC, polyvinyl chloride, because metals being good conductors of electricity. If you happen to touch a naked wire, we will see heaven on earth. So for that reason, it is essential that you use what? An insulating tape, which is polyvinyl chloride. Okay, then we said metals are what? Sonorous. They produce noise when they are hit. The other part, we said non-metals do not have a luster except iodine. Non-metals are not hard because they are generally liquids and gases. The liquid non-metal, bromine. The liquid metal, mercury. We studied non-metals are non-malleable, non-metals are non-ductile, non-metals are not good conductors of heat, non-metals do not conduct electricity except graphite. Okay, non-metals are non-sonorous. These are the physical properties of metals and non-metals. We also studied one more point, I think all of us forgot, high melting and boiling point. Metals have high melting and high boiling point, except cesium and gallium, which melt on the palm because they have low melting point. Okay, after that we studied chemical properties of metals, and we said metals generally react with oxygen to form what? Metal oxide. These metal oxides are basic in nature and they turn red litmus blue. Isn't it? Most of the metal oxides are insoluble in water, but few metal oxides are soluble in water, like potassium and sodium, and when they are soluble in water, they are called what? Alkalis. We also studied that some metal oxide can act both as an acid as well as base. Such metal oxides are called amphoteric oxides, and the two common examples of amphoteric oxide are Al2O3 and ZnO. Al2O3 and ZnO are basically used as amphoteric oxides. Then we studied in the chemical properties next. We said non-metal. So this is all about metallic oxide. So if they form basic oxide, non-metallic forms acidic oxide, and they turn what? Blue litmus red. When metal reacts with water, it forms what? Metal hydroxide. This metal hydroxide basically will tell you that whether it is acidic or basic. Metal oxides are mainly basic in nature. You find that certain metals very easily or very violently react with water, like sodium and potassium, and hence they should be always kept under kerosene. There are metals which react with cold water, like calcium. Calcium reacts with cold water to form calcium hydroxide and liberates hydrogen gas. calcium starts floating on the surface of water because hydrogen gas sticks to the surface of the metal, makes it lighter, and hence calcium floats. Magnesium reacts with hot water and again repeats the same thing, magnesium hydroxide and hydrogen. The hydrogen gas sticks to the surface of magnesium and hence magnesium also floats on the surface of water. Elements like iron, aluminium and zinc do not react with cold water or hot water. They react with steam to form oxides and do not liberate water, do not liberate hydrogen gas. Then we study reaction of metal with acids. When metals react with acid, they form salt and liberate hydrogen gas. Most of the metal tends to react easily, but then the problem is you should not react it with HNO3. HNO3 is a strong oxidizing agent and it immediately oxidizes the hydrogen formed into water and itself gets reduced to oxides of nitrogen like NO, NO2 and N2O. The two metals which react with nitric acid are magnesium and manganese. Fine. Copper does not react with HCl at all. Now coming back to the next part, we also studied what is aqua regia. Aqua regia is royal water which has 3 parts of concentrated HCl and 1 part of concentrated HNO3. It is a liquid, fuming corrosive liquid which basically will even dissolve gold and platinum. Now, we will talk about how do metals react with solutions of other metal salt. This we have studied even in first chapter, even in second chapter, which is nothing but if I take CuSO4. This is a metal salt and I react it with a highly reactive metal. What it will form? It will form, this metal will displace copper. So it will form what? ZnSO4 plus Cu. So what we say that when any metal reacts with a solution of metal salt, highly reactive metal displaces the low reactive metal from its salt solution. On the basis of the displacement reaction, we have what series? Reactivity series. What is the reactivity series? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, and copper, mercury, silver, and gold. This is our reactivity series. The reactivity is slowly decreasing, isn't it? So this is what is that if I take a metal salt solution and I react with it more reactive metal, it displaces the metal from the solution and itself comes out. Okay, so let us understand. We are reading it. Activity 3.12. Take a clean wire of copper and an iron nail. Put the copper wire in a solution of iron sulfate and iron nail in a solution of copper sulfate. So let us understand what we are doing. We have actually taken 2 test tubes. Okay, and in test tube 1, what I have done, I have taken a copper wire in FeSO4. So see, I have kept copper with FeSO4. And in the second case, I have taken what? An iron and put it in a solution of what? Copper sulfate. Okay, this is what I have done. So, do you think here reaction takes place? Here reaction does not take place. Why? Because copper is less reactive than iron. But here the reaction takes place and it forms what? FeSO4 plus Cu. What changes you will observe? The blue color of copper sulfate changes to green due to the formation of what? Iron sulfate. And the iron nail gets coated with a brown coating. This brown coating is because of deposition of what? copper. What did we do? We took a copper wire and dipped it in a solution of ferrous sulfate. This is test tube A. In test tube B, we took an iron A and put it in a solution of copper sulfate. Leave it like that for some time. Okay? Let us read the activity. Record your observation after 20 minutes. In which test tube did you find that a reaction has occurred? In which test tube we find? In test tube B, the reaction has occurred. On what basis can you say that a reaction has actually taken place? There is change in color from blue to green. Can you correlate your observations from activity 3.10, 3.19 and 3.11? Write a balanced chemical equation for the reaction that has taken place. Please write. Test tube A, no reaction. Test tube B, this. What is the type of reaction? Displacement reaction. Name the type of reaction. This reaction is called a what reaction? Displacement reaction. Understood this? So, a highly reactive metal displaces the less reactive metal from the salt solution. A highly reactive metal displaces the less reactive metal from the salt solution. Reactive metals can displace less reactive metal from their compounds in solution or molten form. We have seen in the previous section that all metals are not equally reactive. We check the reactivity of various metals with oxygen, water and acid, but all metals do not react with these reagents. So we were not able to put all metal samples we have connected in decreasing order of their reactivity. Displacement reaction studied in chapter 1 gives a better evidence of the reactivity of metal. It is simple and easy. If metal A displaces metal B from its solution, it is more reactive than B. Which metal, copper or iron, is more reactive? Which metal? Iron is more reactive than copper. Reactivity series I don't need to explain, we have done it before. So this is the last part of it. Now questions from the in-text, try doing it. If you don't, tomorrow we will do this and we will start what? Our ionic bond. This is the last part of metals and non-metals. From tomorrow we will start this, so please take page number 46 as your homework. Let us try doing it because most of the reactions you know, we have done it. So please read page number 46 and come. Tomorrow we will start with how do metals and non-metals react with each other. Thank you.